This is CPM Chapter 5, Problem 171. We are asked to find the derivative for each of the following functions. So with the first one, A, we are given f of x equals 2x plus 1 squared times 3x minus 1 to the third power. And so to solve this, we're going to have to use the product rule. And so we have to take the first, which is 2x plus 1 squared times the second, or the derivative of the second. And so the derivative of 3x minus 1 to the third power is 3 times 3x minus 1 squared times 3, because there is a function within a function. So the outside function is the 3, and the inside function is the 3x minus 1. And so we have to use a chain rule and figure out the derivative of the inside function, and that's 3, and so that's why we multiplied by 3. And then now we have to add the second, which is 3x minus 1 to the third power multiplied by the derivative of the first, and the derivative of 2x plus 1 squared is 2 times 2x plus 1, and there is another function within a function, so we have to use the chain rule. And so the inside function 2x plus 1, we have to find the derivative of that. And so the derivative of 2x plus 1 is 2, and so we multiply by 2. And so when you combine all of this, you'll get 9 2x plus 1 squared times 3x minus 1 squared plus 4 times 2x plus 1 times 3x minus 1 to the third power as the answer. And for B, we get g of x equals 1 over sine x squared. And so 1 over sine x squared, according to the trig identities, also equals cosecant x squared. And so to solve this, we are going to use the chain rule because there is a function within a function. The outside function is cosecant and the inside function is x squared. And so we have to find the derivative of cosecant, and that is negative cosecant x squared times cotangent x squared. And we have to use the chain rule because there's a function within a function, and so the inside function is x squared, and so that's why we multiply by 2x, because the derivative of x squared is 2x. And so when you combine all of this together, you'll get negative 2x cosecant x squared times cotangent x squared as the answer. And then for C, we have f of x equals x times tangent x squared. And so to solve this, we're going to have to use the product rule. And so we're going to take the first, x times the derivative of the second. The derivative of tangent is secant squared. And if you don't know what the derivative of tangent is, you can use the quotient rule to figure that out. And so now we see that there is another function within a function, and so we have to use the chain rule. And so we need to find the derivative of the inside function. So the derivative of x squared is 2x, and so that's why we multiply by 2x, and now we add the second, tangent x squared, and you're supposed to multiply this by the derivative of the first, and the derivative of x is 1, but we don't actually have to put that down. And when you combine that together, you'll get 2x squared times secant squared x squared plus tangent x squared as the answer. And then for the last one, D, we have g of x equals cosine x times root x plus 1, and I just rewrote that as cosine x times x plus 1 to the 1/2 power. And to solve this, we're going to have to use both the chain rule and the product rule. We have to use the chain rule because there's a function within a function, so the outside function is cosine and the inside function is x times root x plus 1, but the inside function, actually there is two separate functions, and so we have to use the product rule. And so we're going to first use the chain rule, and so we have to find the derivative of cosine, and that is negative sine, and then now we have to find the derivative of the inside, but we're gonna use the product rule because there are two different like functions. And so when you take the first, which is x, and then multiply it by the derivative of the second, so the derivative of root x plus 1 is 1/2 x plus 1 to the 1/2 power, and then now we have to add the second, which is root x plus 1, and multiply it by the derivative of the first, and the derivative of x is 1, but we don't actually have to write that down. And then so when you combine this, you'll get negative sine x times root x plus 1 times x over 2 times root x plus 1 plus root x plus 1 as our answers. And